In this section, we're going to do the properties of the logarithmic functions. We're going to use the properties to simplify logs, and we're going to translate between logs in any base. So the log functions properties, they follow a lot along the properties of exponents. So because it is an inverse function of the exponentials. So remember that when we multiplied exponents with the same base, we added the exponents. So for logs, we can take a logarithm, split it into a product, and then add the logarithms. So looking at the first example, we have log base 4, 2 plus a log base 4, 32. Since I'm adding with the same base, I can simplify that by saying the log base 4 of 2 times 32, which is the log base 4 of 64. And we know as an exponent this means 4 to what power equals 64. 4 to the 4th power equals 64, so x equals 4. So you should try the check it outs. Again, remember that same base, we multiply and then simplify if you can. Okay, so now remember when we divided powers, we subtracted the exponents. So likewise, when we take a log and we have a division, we can subtract the logarithms. So if I already have a subtraction of two bases that are the same, that means I can divide. Two to what power equals 8? 3. Okay, so you should try this one. Since we can multiply logarithms, we can also take powers of logarithms. So this is a little bit different than our power to a power exponentials. When I have a log that's raised to a power, that power comes out front as a multiplier. And then I can simplify the log. So the 2 would come out front, so that this is 2 times the log base 3 of 81. Simplify the log base 3 of 81. 3 to what power equals 81? That would be 4. And then I still have to multiply it times the 2. So the 3 comes out front. Then I can simplify the logarithm. 5 to what power is 1/5? It would be negative 1. So this would be negative 3. So try these. And this does end day 1 with the assignment there, and I will continue through day 2. Exponentials and logarithmic operations undo each other since they are inverse operations. So looking at the log base b of b, that equals 1, so it will just be the exponent. If I have the base raised to the logarithm with the same base, it would be whatever you're taking the log of. So think of this first one. I have base of what I'm taking. I have that exponent, which technically comes out front. So we know that the log base 8 of 8 is 1. This I can write 125 as a power of 5. Log base 5 of 5 is 1, so this would be 3. And in the last one, I have the base of 2 raised to a logarithm with the same base, so that's whatever you're taking the log of. So try these. Since most calculators have logarithms in base 10, we can change a log of a different base to another base. So in our example with the algebra, so if we have a log base b of x, I can change it to the same base, log a of x, log a of b. Okay, so for instance, if I have the log base 4 of 8, I can change that to log base 2 of 8 over log base 2 of 4. It's easier to just change everything to base 10 because then we can put that in the calculator. So to change and evaluate the log base 4 of 8, just going to rewrite it. So it would be the same as always taking in the numerator the big number, the denominator is taking the log of the base. And you can put that in the calculator. Put that in the calculator and you get 1.5. We're not going to change it to any other base. So remember, to change bases, it's always what you're taking the log of first over the log of the base. And putting that in the calculator, you get 1.5. So log 16 over log of 8, which is 1.3 repeating. And that takes care of the easier stuff. The application, a little bit more challenging, okay? We are going to use a formula. It's going to be a little bit more difficult, so just bear with me. So we have the Richter scale. We use that to express energy or magnitude of an earthquake. And this magnitude M is related to the energy released in ergs, okay? And it can be expressed by using this formula right here, okay? And we're just going to use that formula, rearrange things, and solve for E. So we know that magnitude is 9.2, so I'm going to substitute that in for M, and the rest of the formula is 2/3 the log of E over 10 raised to the 11.8 power. So the first thing we're going to do is get rid of the 2/3 by multiplying by 3/2. And I think I'll just change the color So you multiply both sides by 3/2. So now we have 13.8 log E 10 to the 11.8. And I know when I'm taking a log of a division problem, I can just subtract. So this will be the log E minus log 10 raised to 11.8. And this, remember, a log is base 10. So this is the same as log base 10 of 10 to the 11.8. And that simplifies to just 11.8. Add 11.8 to both sides. And now I have a logarithmic function that I can write as an exponential. How do we write exponentials? The base of the log is the base of the exponent. So that would be 10. The answer to the log is the exponent, and what I'm trying to take the log of. And if you put that in the calculator, that equals 3.98 times 10 to the 25th. So we're going to try this again. How many times as much energy is released by an earthquake with a magnitude of 9.2 than by an earthquake with a magnitude of 8? So the first thing we need to do is find out how much energy is released with a magnitude of 8. So we're going to follow that same process, solving for E. And forgot the 2/3 here. So now I'm going to multiply both sides by 3/2 to get rid of that. Then I do the subtraction because I'm dividing. I know that that's 11.8. Add 11.8 to both sides. Write as an exponential. And evaluate. Since it wants you to do a comparison, you just divide your two magnitudes that you had. So it would be 3.98 times 10 to the 25th, because that's the bigger number, divided by 6.31 times 10 to the 23rd. And this equals 63. And this ends lesson 7-4.